For the system of equations shown here, we want to find the value of A if there's a unique solution, no solution, and infinitely many solutions. So let's look at our equations. So we have x plus y plus z is equal to 2. Then we have 2x minus y plus z is equal to 1. And then negative x take y plus az is equal to 10. So let's call this 1, 2, and 3. Now straight away, looking at the x's and the y's, I can see that if I do 1 plus 3, the x's disappear, the y's disappear, and then I get 1z plus az's. So that z plus az is equal to 12. So z into 1 plus a is equal to 12. So let's think about this. If I have 0 z's is equal to 12, there's no value of z that works. So if a is equal to negative 1, we're going to have no solution. If a is not equal to negative 1, then we'll have some number of z's equals 12. And that means that we can find z. Z would be equal to 12 over whatever that number is. And that means we can substitute back and we can find y and we can find x. So if a is not equal to negative 1, we'll get a unique solution. Now, how can we produce infinitely many solutions? Well, the only way to get that is something of the type 0z equals 0, and we can't get that. So there's no way of getting infinitely many solutions for this problem. So if a is 3, we want to solve the system. So we have x plus y plus z equals 2. 2x minus y plus z equals 1. And then negative x take y plus 3z is equal to 10. So 1, 2, 3. So let's do once again 1 and 3, getting rid of both x and y. So that would give me 4z equals 12, so z is 3. Substitute into, say, 1, that gives us x plus y plus 3 equals 2, so x plus y would be negative 1. And if we substitute into 2, that would give us 2x minus y plus 3 equals 1, so take that to the other side and that would be negative 2. So let's call this one 4 and this one 5. So if we add them, we get rid of y, so 4 plus 5 gives us 3x is negative 3, so x is negative 1, and if x is negative 1, that means that y equals 0, so we have x is 1, y is 0, z is 3.